In this video we are going to look at Final Exam Part 1. So you can see that Lecture 25 is about reviewing for the final, Part 1 of the final exam. Part 1 of the final exam is worth 50% of the final exam grade. No work is required, nor is it graded, so you do not have to submit this part on Blackboard. All you need to do is the part on MyOpenMath. You will have 90 minutes to answer the questions, and this is very important. The questions appear in random order. Now, as we go through this practice version, the questions will not be in random order. Instead, we'll be looking at a particular copy that will be available for all of you to look at, where the questions are not randomized and everybody will have access to the same version of the questions that I have. For one, we need to find the angle between 0 degrees and 360 degrees that is coterminal with the given angle here. So in order to do that, all we need to do is start with that given angle, negative 847, and then we need to just add multiples of 360 degrees. So if I add one copy of 360 degrees, you can see that I'm only at negative 487, and I need to be between 0 and 360. So I'm going to add another multiple of 360. Nope, still not between 0 and 360 yet, so I better add another multiple of 360. And now I can see that I have 233 degrees, which is between 0 and 360. So 233 is my answer. And there you go. Now, if the number that is given to you is a positive number and it exceeds 360 degrees, then you would subtract multiples of 360 degrees from that large positive number until you reached a number that was between 0 and 360 degrees. Question number 2. We need to evaluate this tangent, but this tangent is given in degrees, minutes, and seconds. So what we want to do is convert seconds and minutes to degrees like this. 194 degrees stays as 194 degrees, but we need to convert 8 minutes to degrees. Remembering that there are 60 minutes in 1 degree, we can rewrite 8 minutes as 8 over 60 degrees. And since there are 60 seconds in 1 minute, there would then be 60 squared seconds in 1 degree. So that would be 26 over 60 squared degrees. So what we want to do is we want to type all of this into the calculator. But remember, we are evaluating this for the tangent, so we need to make sure that we are in degree mode and that we are also including tangent into our calculation. So first I check that I am in fact in degree mode. Then I am going to use tangent 194 plus 8 divided by 60 plus 26 divided by, and 60 squared is 3600. And now I can see that the answer is 0.2519, etc., rounding to the nearest thousandths. So that would be 0.252. And that, in fact, is the answer right there. For question 3 here, we have a basic SOHCAHTOA problem, so I will do this one on the board. Now, as we're going through these problems, let me remind you again that the problems on the real final exam will be shuffled. And so don't expect that question 3 will be this particular question. Somewhere in the test you will have this question, but the questions on the final are shuffled. Okay, so for this one, we want to pay attention to the fact that we already know A is 6 and B is 2. So then this gives us the diagram that we see right here on the board. And so what we need to do first is use Pythagorean theorem to find the length of the hypotenuse, which is side C. Okay, so I've shown a whole lot of work here for solving for C, so you can pause the video if you need to see all this work in detail, but the basics is use the Pythagorean theorem. You end up with c squared is equal to 40, So then C is equal to 2 square root 10. Next, to solve for the angles, you can choose to solve for capital A or capital B first. It doesn't matter. So arbitrarily, I'm just choosing capital A. I note that I have been given these side lengths. You can, of course, use the exact value for C, but these are whole numbers, so they're a lot easier to work with. The tangent of angle A is equal to opposite over adjacent, 6 over 2. So that means that A is going to be tan inverse of 6 divided by 2, which is 3. And as you put that in the calculator, remember to be in degree mode. We are in a triangle. And now here you can see that I've typed the tan inverse of 3, and that has given me 71.56, etc. Now we are rounding to at least one decimal place, so 71.6 should work. Next, to find angle B, all we need to do is subtract angle A from 90 degrees, because the sum of the angles in a right triangle are just like any other triangle. They add up to 180 degrees, except with having a 90-degree angle already, that means the acute angles have to add up to 90. So we just subtract 71.6 from 90. And then B is then equal to 18.4 degrees. And here it is on the calculator for you. Now I also want to get an approximation for 2 times the square root of 10. I can see that 2 times the square root of 10 is about 6.3. So that when I go back to this answer here, I'm going to type in 6.3 because I need to give all answers to at least one decimal place. You can go beyond 6.3 if you like. It's just at least one decimal place. And then we said that angle A is 71.6 and angle B is 18.4. And that takes care of question number 3. So now moving on to question number 4, we're going to be sketching a graph. So we want to make some observations first. Here we have the amplitude. The number out in front is 3. So that means as we oscillate, we're going to be going as high as positive 3 and as low as negative 3. And then we want to note that we have this 1/3 value right here. And remember that this B value here helps us determine what the period is going to be. And so since 2 pi divided by B is going to be the period, then that means that 2 pi divided by 1/3, which is 6 pi, is the period. So that means that this graph of cosine is going to repeat every 6 pi. Now cosine typically starts at the highest point, which would be right here, unless it's shifted to the right or the left, and we do not see any shifting right or left. Since we are going to repeat the graph every 6 pi, the next time we get up to this highest point again would be at this positive 6 pi over here, and that means that halfway in between 0 and 6 pi, which is 3 pi, is going to be the lowest point, and the lowest point is going to be at negative 3. Again, we're going as high as positive 3 and as low as negative 3 because of the amplitude value here. And now for the quarter cycles are 1.5, and so at 1.5 you're going to have the graph cross the x-axis here, and at 4.5 you'll have the graph cross the x-axis here. So then this is enough notes for us to be able to use the graphing function, and you can choose to either do the highest point and the lowest point, or you can do a midpoint. Now, since one of my midpoints is going to be halfway between pi and 2 pi, a halfway point is a little less clear than an exact whole number or an integer. So I'm going to go ahead and use the lowest point and the highest point. Recall that my lowest point was at 3 pi negative 3. And then my highest point, remember, was back here at 0, 3. So then that ends up being my graph. Now we can check the answer here. You can see that you get the exact same graph. Now if you're off just a hair when you plot this, do remember that I check all graphs as we go through. I always check answers to see why you may have gotten something missed, and so that I can give you back points if you deserve them. More of this test is going to be having you analyze graphs rather than graph them, because you have access to a graphing calculator on this exam. So it would not be a whole lot of difficulty for you to just graph into a graphing calculator. So I do want to know whether you really understand this topic, and so we're going to do that by analyzing this equation for starters. So the amplitude, remember, is that number right out in front, and so the amplitude is 6 in the equation, and we can work through it a little bit at a time. So here the 6, the number out in front, we said is the amplitude. And then here we have the sine of 11 pi 6. Now this 11 pi 6, and I'll fill this part in just a second, but this 11 pi 6 here is the b value, and the b value helps you determine the period. Remember that the period is 2 pi divided by the b value, and so if you divide by 11 pi 6, you end up with 12 over 11. So that means that the period is going to be 12 over 11. Now, to determine the horizontal shift, you need to factor out the 11 pi 6 from this part of the function. So if we were to take 11 pi halves and divide it by 11 pi 6, then that would be the same as multiplying 11 pi halves by 6 over 11 pi, because remember, if you divide by a fraction, you multiply by the reciprocal, and then that easily simplifies down to 3. So once we know that we have a 3 value here, we can write this part of the equation as x plus 3. And then this tells us our horizontal shift. The shift is going to be 3, and since this is a plus 3, that is going to be to the left. We're always going to move in a counterintuitive direction when it comes to horizontal shifts. Horizontal shifts, if you see a plus, it actually means move left, whereas a vertical shift, which is what we have right here, is going to be more intuitive. When we see a plus, it actually does mean move up. So if we are shifting this whole graph up 5, that means we have a new midline. Instead of the x-axis being the midline, we get the equation y is equal to 5, and you don't need to write y equals 5, you just need to write 5 because the y equals is already here for you. Here for question number 6, we are going to analyze the graph so that we can write the equation. Now we already are told that the equation is a transformation of the sine graph, so we know we're going to use sine and not cosine. And so now we just need to determine amplitude, period, and phase shift. There is no vertical shift. You can see that we are oscillating between -2 and +2, so the midline remaining at the x-axis means there is no vertical shift. The amplitude is 2 because we're oscillating between +2 and -2, so we'll start with typing in 2. The next thing we want to notice is that because we are going in an upward direction first, we are going to be using a +2 and not a -2. Had we been going downwards first, we would be using a -2. Now, the period of this function is from peak to peak or trough to trough, or you can also just look at a half cycle and double it. So right here we have a mark at -3.5, and this is a +1/2, which means that the entire half cycle is 4. Likewise, you could also look at this point right here being 4.5 pi, and then this point is -3.5 pi, and on the number line that we have from 4.5 back to -3.5 is a distance of 8. So that means that the period is going to be 8 pi. So I think about the numbers first and then I add pi, so sorry if I said anything that was a little confusing. Ultimately, what you need to hear is that the period of this function is 8 pi. So here is one full cycle, and that one full cycle is 8 pi. So then what does that mean for our function? Well, we use the period to determine the b value. So 2 pi divided by the period is the b value. 2 pi divided by 8 pi is then equal to b, so 1/4 is equal to b. So then when we go and type this in right here, we have 2 sine, and then our b value we said was 1/4. And now we're going to have another set of parentheses for the fact that we are shifting to the right pi halves. A shift to the right pi halves is represented by x minus pi halves. If you shift to the left, it's a plus. If you shift to the right, it's a minus. Now, You can also write this having used the distributive property, and that's the other alternative. In fact, right here you see that this isn't, well, this is not using the distributive property. This is writing the 1/4 as a different setup for the fraction. But you could write it either way. You're going to have the exact same result. If you use the distributive property, the other way of writing this would be 2 sine 1/4 x minus pi over 8. So this is also acceptable, although this is a whole lot more straightforward and easier. So I just recommend you do it this way, or you could do it the way that the MyOpenMath program has shown you. Okay, here we come to another graphing problem. So what we want to do is consider the fact that first we have a sine graph. Now typically a sine graph is going to start at 0, and then since it has an amplitude of 2, it would come up to 2 at a quarter cycle, and then come back down to 0 at the half cycle, etc. Now, in this particular case, though, we are shifting. I did, by the way, already observe that because the b value is equal to 1, that means that the period of the graph is 2, and so you can, 2 pi. So that since the period is 2 pi, you can see that the graph that I have drawn here has a quarter cycle at pi halves and a half cycle at pi. So what that means is that the graph here that I have drawn is your basic y equals 2 sine x graph, where there's no horizontal shift, no vertical shift. The period is the standard 2 pi period, and the only change is the amplitude. Now in our particular problem, we are going to take this same graph and we are going to shift it to the right by pi. So if we shift it to the right by pi, it's going to move this point right here all the way over there. What that will mean is that the resulting graph is going to be a vertical reflection of this graph. In other words, the blue graph could also be written as y equals negative 2 sine x. Negative 2 sine x is equivalent to 2 sine x minus pi. Okay, so for the sake of graphing it now, I know where it's going to go. So I can use this one right here that has the midpoint. The midline point is going to be at the origin, and then I'm just going to go down at a quarter cycle all the way down to negative 2, and then that is my graph, and you can see right there in the answer. Okay, for question number 8, we're given a graph, and now we need to write an equation, and this can be sine or cosine. We see also that we have to find the amplitude. The b value in this case is written as a k, and then c is the vertical shift. So in order to do this, we want to start by finding the midline. The highest point is at 3, and the lowest point is at negative 5. Halfway between 3 and negative 5 is negative 1. So you can see that we have our midline then at y is equal to negative 1. So that is going to be the c value that we're looking for there. With regards to the amplitude then, the amplitude is going to be the distance from the peak to the midline, or the distance from the midline to the trough. Either one is going to be the amplitude, and you can see that in both cases here we have 4. So the a value is going to be 4, although we could end up with a positive or a negative value depending on the direction our graph is heading. Already we see that we are in a horizontally stretched positive position, which means that this is a cosine graph that is positive. And so I put this over by the cosine graph, and this is a positive value because the cosine graph is starting at the highest point. And then the last thing we need to figure out is this k value. This k value here is the same as the b value, and so we would use 2 pi divided by b equation is equal to the period, except we're going to call it 2 pi divided by k in this particular case. To find the period, we go from peak to peak, or you can go from trough to trough, but in this particular case, since we start here at negative 10 and go to 0, we can see more clearly from looking at this peak to peak that we have a period of 10. So that means that when we're looking for the k value, we need to find something that is going to give us a quotient of 10, and that value for k is found by cross multiplying, and so k is equal to 2 pi over 10, in other words, pi over 5. So then as we look at our final answer here, we see that we have 4 cosine pi fifths x minus 1. And here's that same answer as given by MyOpenMath in a typed up format. Okay, then for question number 9, we're going to continue by looking at graphs, coming up with the functions for them. Here we're looking at not sine or cosine, but this is either going to be tangent or cotangent. And in this particular case, we want to start by observing what is the period of this function. So we can see that between copies there is a distance of 4, and so if the period is 4, now we need to find the b value. Now tangent and cotangent are different, that instead of 2 pi divided by b, we have pi divided by b, because the standard period for tangent and cotangent is actually a single 1 pi. So that means that our b value is going to be pi divided by 4. Okay, so next let's look at the graph more closely. Knowing that the period is 4, I went ahead and put the asymptotes in for this middle copy. 2 to the right, 2 to the left, that's a total of 4. So when you have a graph that is going to be on either side of the y-axis, the same distance to the right, same distance to the left, that's going to be a tangent graph, and that graph is not shifted right or left, so that's very nice. And it's a positive orientation for tangent. So this is going to be a positive tangent, and it already has a period of pi fourths, a period of 4 with a b value of pi fourths. So the last thing we just need to determine is if there is a vertical stretch. If we look at the quarter cycle is going to give that away for us. So a quarter cycle is going to be a distance of 1. So if we come over here to this point 1 and follow it up, we see that there is a stretch all the way up there to positive 4. So that means that this function is being stretched by a factor of 4. So we can then write this as 4 tangent pi fourths x. Again, it's tangent because we are in the middle here. Had the graph look like this sort of graph is a cotangent graph, the cotangent graph and the tangent graph can be transformed into each other, but the key difference that you're looking for is not just the orientation. This is a positive orientation for tangent. This is actually a positive orientation for cotangent. It has a opposite positive orientation. But in particular, the fact that this one has asymptotes at the y-axis and at the period length gives it away that this is a cotangent graph, whereas the tangent graph straddles the y-axis. And then here is the typed up answer from MyOpenMath. Okay, moving on to question 10. Now for question 10, we're looking at cosecant or secant. So the best way to figure that out is to figure out what graph is in the blank in between. What graph is this the reciprocal function of? And the first observation I want to make is that the distance between a positive 3 and a negative 5 is 8, and the midline then is negative 1. So whatever graph is oscillating back and forth here, it has a midline of negative 1. And this is also then going to be a vertical shift for the graph's final answer. Now next I want to look at the period. You can see here that the period is going to be, here I'm at like a little to the right of negative 4, and here I'm a little to the right of positive 1, which is a distance of 5. So the period for this graph is 5. And then halfway in between, you're going to see the asymptotes for this graph. Sorry, not halfway in between. At the quarter cycles, you're going to see the asymptotes for this graph. So if we draw those in, then we can more clearly draw the function that this black graph here is the reciprocal of. Because now we know that this reciprocal graph is going to cross the midline every time we have an asymptote. Furthermore, we know that its trough is going to be at the highest point of this black curve, and the peak is going to be at this lowest point of this black curve. And so now when we connect the dots, we can see that what we have here is a sine graph. The orange graph then has an equation of 4 sine of something minus 1. The 4 is the amplitude. We already said that from negative 1 to positive 3, or from negative 1 to negative 5 is a distance of 4. We can see the positive orientation of that sine graph, we can also see that we have shifted down 1. We got that in the very first observation. And so we just need to fill in the b value here, which we can use the period to figure that out. So that's going to be 2 pi divided by the period. So that would be 2 pi over 5. So that would be the orange graph, and then the black graph is the reciprocal function of that orange graph. And so the black graph then would be y is equal to 4 times cosecant of 2 pi fifths x minus 1. And here is the answer typed out by my open math. Next, I'm going to do questions 11, 12, and 13 on the board, so you can go ahead and take a look at them here, and then I will be putting them up on the board. So first I have this expression here that I need to simplify. So I want to start by rewriting cotangent as cosine over sine, and rewriting cosecant as 1 over sine. By doing this, of course, now I have a complex fraction. Now, complex fractions are easy to simplify. If you just look at the little denominators within the complex fraction, we have a sine t, and then the denominator of this part is simply 1. So that means that if I multiply the numerator and the denominator by the least common multiple of all of those little denominators, which is just sine t, then I can clear this complex fraction down to a regular fraction. So then that is going to give me cosine of t divided by 1 minus sine squared t. So this is not a proof, so you don't have to show lots of steps. You can go ahead and cancel the sine t with this sine t to result in cosine t. Likewise, this sine t, when you use the distributive property, this sine t right here in red is going to cancel with the 1 over sine t, giving you a 1, and then a sine t times a sine t is a sine squared t. Now at this point we can see that we're looking at a variant of one of the Pythagorean identities, since cosine squared t plus sine squared t is equal to 1. That means, therefore, cosine squared t is then equal to 1 minus sine squared t. So that's a really nice observation to make, so that when we're looking at doing a substitution here, we can replace the denominator with cosine squared t. So now I have a cosine to the first power in the numerator, cosine to the second power in the denominator, so we see cancellation here, and the result then is a 1 over cosine t, and if we write this without using any fractions, the reciprocal of cosine is secant. So now going back to my open math, we see that we actually have the answer that we found on the board. Okay, so now let's look at question number 12 on the board. Question 12 gives us a product, and we need to use the product to sum formula, the cosine one, because we have a cosine. So here we see that A is 45b and B is 5b, so we're just going to use this formula here. Now the 20 is going to start out in front, and then we're going to take this part right here and replace it with the formula. So the formula has a 1/2 out in front, a plus b, a minus b, and remember that a is 45b. And b is 5b. So then when we simplify this, we end up with 20 times 10, which is 10. Then we have cosine of 50b plus cosine of 40b, and then we need to use the distributive property. So we end up with 10 times the cosine of 50b plus 10 times the cosine of 40b. Going back to my open math, we see that we have that very result right here. Okay, so lastly, now we're going to look at question 13. Here we have a cosine minus a cosine, so we're going to use the sum to product formula, cosine minus cosine, and so we'll go ahead and copy all of this the same. We're going to be using, I'll copy the right hand side here and just not fill in A and B just yet. And then we just need to look at what is A and what is B. So we see that the A value is going to be 21.5p. And the B value is 12.7p. Now, 21.5 plus 12.7 is 34.2. Yep, and then 21.5 minus 12.7 is 8.8. So this then gives us -2 sine of 34.2p over 2 sine of 8.8p over 2, which then further simplifies into 17.1p and 4.4p. So now we can go back to my open math. And we see the -2 sine of 17.1p sine of 4.4p just like we had on the board. Great. So now let's look at questions 14 and 15. Now for number 14, you want to start by coming up with an angle that will replace this expression. So I chose theta. Let theta equal tan inverse of 5 over 6. Tan inverse only exists in the moon as a non-technical trig, but it goes from -pi/2 to +pi/2. So in this particular case, we're not looking for an exact angle. We're just going to go ahead and just draw a triangle. And since we have +5 over 6, that tells us that we are looking at a first quadrant triangle. Tangent of theta, theta would then be right here next to the origin, is going to be in a right triangle opposite over adjacent. So now we're going to try to figure out what is the sine of theta. So using the Pythagorean theorem, if we call this side C, then we end up with C is equal to the square root of 61, using a squared plus b squared is equal to c squared. So the sine of theta, remember, is going to be opposite over hypotenuse. So that would give us a 5 over the square root of 61, which when we rationalize it, we end up with 5 root 61 over 61. So that's why we need to have an exact value, no decimals for our answer. Now, they did not rationalize the denominator here, so I guess if you don't rationalize your denominator, you won't get in trouble. Okay, question 15. Now we're going to go ahead and look at this one. We're again looking for an exact value. So in this particular case, we are going to use the unit circle to find the sine of 11 pi 6. So 11 pi over 6 goes from 0 all the way to here. And so this point right here has the x-coordinate root 3 over 2 and the y-coordinate of -1/2. And that tells us that the value for the sine of 11 pi 6 is then negative 1/2. Now to get this next answer, what we want to do is remember that the inverse of cosine only goes from 0 to pi. We call this the rising sun, or I do at least. That's not in trig textbooks. So if cosine inverse is right here only from 0 to pi, we know from the unit circle that the value right here at 2 pi thirds is going to have a cosine inverse value of, a cosine value of negative 1/2. So cosine of 2 pi thirds is negative 1/2. So that means that our answer here is 2 pi thirds. And my mouse is not really responding very well to me right now, which tells me that this video is getting a little long. So this would be a great stopping point for the end of the first half of this lecture, and then I'll start a new video for the second half of the lecture. But let's go ahead and just get the answer real quick, and that would be 2 pi thirds.